one of the challenges we had with Go is that it's really not meant to be like an ultra lightweight runtime. It's a very full featured runtime. You have a garbage collector, you have Go routines, you have all of these different language features, which are very, very nice to work with, but they can get heavy.
Had you written any Rust before going on this project?
No, not a line. And I think that's a big part of why I was so resistant.
Not a line.
Languages in general, I think once you really learn and know one, it's easy. I think, in my opinion, it's been easy enough to kind of pick up a second and a third with time.
What did you think of the Rust ecosystem?
Go has an army of very talented developers led by Rob Pike at Google. All that said, Rust is pretty mature. There's a lot of support, and you are going to probably spend more time reading library code than you were expecting. I don't think that's a bad thing. You pick up a lot of the patterns and a lot of the idiomatic strategies that you're going to want to use anyway. So, but it is different. I think it is harder than Go.
You're like a big fan of App Runner, right? You're like one of the two people that loves App Runner.
I can't recommend that anyone use App Runner anymore.
One of my biggest complaints about AWS is it can be really hard to know which services are like soft deprecated. What's up, everybody? This is Alex, and we have a great show for you today because AJ Stuyvenberg is on the show. AJ is one of my favorite people. We worked together at Serverless. Now he's doing awesome things at Datadog. He just wrote the sweet blog post on rewriting their Lambda extension from Go to Rust and some of the reasons around that. Very like measured approach to doing a rewrite, which is a risky endeavor. Learning Rust and doing Rust. So like lots of cool things there. He also has like really good, I think, just like general AWS serverless ecosystem thoughts. And so we go back and forth on some of those things and always learn a lot from AJ and enjoy chatting with him. So, if you have any questions, comments, people you want to be on the show, feel free to reach out to me or to Sean. And with that, let's get to the show. AJ, welcome to the show.
Thanks, Alex. It's great to be here.
Yeah, man. I'm excited to have you because you're one of my favorite people. We worked together at Serverless and like had a great time there. And it's just been super fun to like watch what you're doing since then. You're now staff engineer at Datadog, AWS Serverless hero, reInvent speaker, all kinds of like expert in all these different areas. I guess that's like the high level stuff. But for people that don't know about you, maybe you want to introduce yourself.
Thanks. That's actually, that's too kind. But yeah, I'm a staff engineer for the Serverless group here at Datadog. For the listeners before this, Alex and I did work together at Serverless Inc. He's a pretty good boss. So if you get the opportunity, you should try and work for him. Learned a lot there. And I've been in the AWS and serverless space for a number of years now. I think I deployed my first Lambda function in 2016 or 2017. So pretty early on, but it was still really, really rough. We're talking like drag and drop zip file time, those types of things. So it's been a really fun journey. And here at Datadog, I've been in charge of kind of everything we do that's not a VM, a K8s cluster, a bare metal box, anything that's kind of managed compute. And that sort of bleeds over into the managed data store services, things like DynamoDB, Alex is quite familiar with, of course, and SNS, SQS, kind of the other ancillary cloud products too, like Google Cloud Run, Azure App Services, that kind of thing. So our group kind of encompasses that. And it's a lot of fun. I think it's a really cool space to be in. It's been a really fun ride, and we've had a lot of hits, so I'm excited to talk about it.
Yep. Yeah, I know. It's been like really fun to watch your journey at Datadog because I'm just like so jealous of all the stuff you're learning because you're like always just sharing all this interesting stuff. And part of it is like you're just like a big time learner, like always wanting to like dig into stuff and share it. But I think like it's such a perfect fit for you because you get this amazing scope and scale at Datadog and like all the low level stuff that's going on there, and you just get to see so much data. And it's like I'm just really jealous. I think it's cool like what you're doing. So I do want to talk about your journey at some point. But I want to start with like why we brought you on the first place. We've been sort of talking about this for a while. And you just wrote this blog post about like rewriting Datadog's Lambda extension, rewrote it in Rust because rewrites are always an awesome idea. And Rust especially is a great idea. I guess like maybe tell me sort of about that. I guess I want to say first, just like some background on like why this is so hard and scary. Not just the rewrite, but like the extension itself, right? Because like Lambda is this dynamic compute environment where it's just like spinning up on demand. And when it does spin up, usually it wants something super quickly, a response. So you need to be able to spin up super quickly because you're like sort of wrapping the customer's code. You can never fail. No matter what happens. But you also have like these extremely variable workloads because there's like a million different languages and everyone can bring their own language. The execution time can be a few milliseconds. It can be 15 minutes. That's like super varied. Just like all this hard stuff that's going on that just like scares the crap out of me if I was doing any of this stuff. But anyway, with that sort of background, I guess tell me about this rewrite. Tell me about the problem and like and what's going on there. And we'll dig in.
Yeah, absolutely. So I think you hit on a lot of the interesting notes, and to kind of intro the fact is Lambda on the surface level seems very simple, and it is. But to make something simple, you have to solve a lot of hard problems, and then kind of give people pretty firm boundaries. And a lot of the things I think people complain about with Lambda are the result of like hard-won distributed systems lessons. So I'm talking about things like hard capping the duration that a Lambda function can run. It's like no more than 15 minutes, and then when you put a limit on that, that is it. Like that process is killed at that time, where whatever you set, maybe it's 5 seconds or something, capping the amount of memory, and with it in Lambda, the amount of vCPU cores you get. All of these things are kind of hard fought lessons that we learned from the maturation of containers and the journey to, from like unmanaged compute to kind of more managed compute. Even the people that are kind of like hardcore hosted yourself people end up using things like C groups to limit the amount of resources that a single processor application can consume. So when we're talking about building a Lambda extension or like a sidecar process, which collects telemetry data, ships stuff back to Datadog or wherever you want to send it, one of the hard parts, as you alluded to, is that it exists in the hot path of a request. And I'll unpack that here. In a typical load balanced workload, in like a typical big server kind of infrastructure, what you have is a load balancer and then a number of worker cores or servers behind that load balancer. And that load balancer is kind of sitting in front and receiving all the requests, all the traffic. And it will not send a request to a server if that server is not like responding to health checks and is saying, okay, I'm ready to receive data. And in Lambda, the problem is that happens on the hot path. So that load balancer is actually blocking a request and saying, okay, I'm gonna wait on this request until that Lambda sandbox is ready, which means every millisecond of latency you introduced in your initialization time or your cold start is a millisecond that the customer feels and has like a bad experience on. Now, it's true that at scale, cold starts are like, somewhere between like a tenth and a half of a percentage point of all of your Lambda invocations. But that still means like a decent amount of people are experiencing them. And as your scale lowers and as like the actual traffic lowers, those cold starts become more frequent. So it is a big issue. And especially at our scale, we have customers that are running the gamut. They either have like one request every few hours and maybe don't care about it. Maybe it's an asynchronous process, but they also have, Lambda functions that are doing hundreds of millions of executions every day. And as a result, it kind of has to work in all modes. And I think that was what initially led us to look at like a very specific rewrite in Rust. And initially, the Lambda extension was built on Go. It was kind of a fork of our main Datadog agent. I think Go is generally very well suited to Lambda. I would suggest if you're looking to write a Lambda extension, explore Go and Rust. One of the challenges we had with Go is that it's really not meant to be like an ultra lightweight runtime. It's a very full-featured runtime. You have a garbage collector, you have massive Go routines, and I shouldn't say massive. You have Go routines, you have all these different language features, which are very, very nice to work with, but they can get heavy, and especially when like the code base gets very large, you end up with just like it's much more difficult to take a really large thing and pare it all the way down to the core essentials versus like start from the beginning and go up. So at some point in the last year, we were exploring all the different paths we could to make the Go agent work in Lambda, and we weren't able to hit our performance goals. And I'm talking about we were like ripping out anything within a init call in Go that was blocking the cold start. We were talking about trying to register as soon as we possibly could, and all these things. But just the sheer size of everything we wanted to do made it too large, and we weren't fast enough. I think our notes were like 450 milliseconds of like customer impacted cold start time. And that's when we started looking at Rust. And the big benefit there is, of course, like you get memory safety too. So it's like two things, right? Get out of the hot path as fast as you can and get some memory safety.
Yep. And you're talking about like, all these being on the hot path. It's something your customer feels, and I'm guessing that people are like less tolerant of like third party introduced slowness too. It's like, hey, if I wrote this crappy code and it slows down our thing, it's like, well, I have other priorities. But if it's like, if I'm pulling in this thing and it's being slow, it's like, even though it's heavily optimized, there's just like less tolerance for it. So it's even harder that way, which is like a tough bind to be in.
Oh, absolutely. I mean, no customer wants that experience where they add your product and then it starts getting slow and they're like, well, what the heck? Nobody wants to have that. So that's one of the core requirements. It can't do that.
Yep. So you mentioned that the original one was there's like the Datadog agent that runs on a server in the background, or like collecting metrics and forward them along. And basically, the Lambda extension was a forked version of that. And I guess like how like was that most of the whole thing was in there originally, the thing, but maybe just built to run on Lambda, or like what did that sort of look like?
Yeah, it was in Go. We used build tags, so we had like specific like entry points. We had like our own main.go. We had our own entry point to the program. We were stripping things that we didn't need out as best we could. We had explored using a system called Go, which I'm sorry, we had explored using Go plugins, which are a feature of the language which allows you to ship separate binaries and then load it. It's similar to like dynamic library loads like DLYD. The downside there is that one of the goals was to get the size of the compiled binary down as low as we could. That impacts your cold start time. And when you do that with Go, it doesn't know which plugin you're going to load, which features of the standard library are going to be included in any of it doesn't know which features of the standard library are going to be included on any of the plugins you load. And as a result, every single plugin includes a full copy of the standard library. So it's sort of self-defeating for us. Where it kind of inflated the overall size. And that was kind of where we abandoned that project and started looking at a rewrite. Around the same time, we had like seen a couple of crashes. And one of the big downsides of Lambda is if any extension process crashes, the whole function crashes right there. And that that's something that the main agent in like a server doesn't contend with, right? Because it's like either a totally separate pod, and then it's using HTTP to network and receive telemetry data from other machines or other pods. And inside of Lambda, that's not the case. So it became like a really big focus area for us to have like a crash-proof system, or as much as possible.
Gotcha. Yep. And what was sort of like the timeline on this road? Like when you released the initial extension, was it right away like, this is good enough and this can work, but we realized there's some cold start issues and things like that, and you spent a lot of time improving that in Go as best you could, and then at some point you were just like, hey, we're not going to hit what we want, or like what did that sort of look like?
Well, that's a great question. I think with the benefit of hindsight, maybe the story is told a little differently, but I think it's important to call out that like when extensions were launched in 2020, cold starts over the board were still very bad. Like across the board, cold starts were a problem everywhere. And Lambda's continued to invest engineering time in improving that, including things like Java Snap Start or the container caching and loading we've talked about in the past. And all these important developments have happened kind of since then. So at the time, I think it was totally well suited, and customer expectations get better every year, get higher every year. So it keeps us on our toes. And at the same time, we were like obviously doing everything we could to get that cold start down. But a certain element of gravity exists when you have all these, thousands of lines of code and trying to remove them while still being completely compatible is like a very difficult challenge. And that's where we landed on this, like, well, we have the API boundaries that we need for this. And actually, I think if we really talk about ideal state from a ground up, we don't really need a garbage collector as a Lambda extension. And a big part of that is because, right, you have one function execution process per extension, right? It's one-to-one in the sandbox, which means I don't have to aggregate or like balance fairness across a bunch of different clients in the way that the main Go agent does. So when we looked at that carefully, it was like, well, we're going to have to rewrite it all anyway, basically, right? To make the optimizations necessary to hit the cold starts we need, we would basically rewrite the whole thing. And then we were like, well, we don't need the garbage collector. So why don't we just manage our own memory? And Rust became a very apparent tool.
Yep. Interesting. Okay. So you actually thought, hey, potentially we could rewrite this in Go and make it significantly faster, but probably not to the Rust levels that you got down to, but faster than like sort of the original Go agent that you had.
Yeah, exactly. And we had gone a really long way down that path. I think the binary we were producing was like tens or 20s of megabytes smaller than the agent at the time produced. We had stripped out a ton of things which were kind of like irrelevant for within Lambda, and at the same time it was like very difficult without kind of rewriting the core of the aggregation and the client fairness and the balancing and all these app like different components. And then we were like, well, we're gonna have to rewrite this anyway, and if we don't need a garbage collector and we would rather have crash safety, there's better tools for that. And it's been a great experience. I think it took us. We started the process in March 2024. We were live for beta users by, it was like late summer, late August 2024. We were live for beta users, and then November at reInvent, we went GA. So it was actually pretty quick.
Yeah. And like, Tell me about that rollout, especially like with the beta users. How did you find these? Like, were these people that were having issues, or maybe like clients that you're in touch with a lot? And how do they even roll it out? Do they pick like some low value functions where they can at least start testing it, or like what did that rollout look like?
Yeah, that really varies by the customer. So we did a number of things. We identified, first off, we have teams inside of Datadog that rely on Lambda heavily for different features and different capabilities. So we identified like internal customers early on. And I'm talking about like, I think I had a first build in people's hand in June or maybe even May. Like a very like 2-3 months, we had like the bare bones of like metrics and logs and traces working, and at that point, we were getting it just into internal users and trying to see what happened. And we discovered a bunch of problems. Realized there was like compatibility issues with different versions of tracing libraries that are kind of out there in the open source world, and we were scoping that all out and kind of discovering the unknowns that we had to learn. Now, at the same time, obviously, we had like a number of customers that had voiced their dissatisfaction with the initial cold start time that we had. So we were kind of pinging them and going directly and saying, "Hey, would you want to try this new thing out? Would you want to try this next generation extension out?" And yeah, of course, like a lot of people were just like willing to try it in staging, and we asked them to obviously like try this in a very low risk environment in a safe way, and then you can roll it out. When it came time to release it into GA, and in fact, actually, when we released it into beta, the way we did this was kind of clever, I think. The bottle cap process, the Rust process, boots first, and it reads the configuration file in the environment, and it decides if anything there is unsupported at that time. So we had like a bare workload of, I think it was like metrics, logs, and traces for like some runtimes, but not all. And if it was custom, we had no idea. And we were like, well, just to be safe, we're going to just boot into the main Go agent. And that failover, just like reading that environment, was about 4 milliseconds. And we were like, okay, we can eat that cold start time. And at least if we have to fail over, we can fail over. And then we were able to boot the main Go agent. And they were two different processes deployed in the same Lambda extension. And the Go agent was just dormant until the Rust agent booted it. And we had that for months. And then end of November, we switched that. And that became like, we only failed over, initially you had to also opt in. So it would read the environment variable, and then it also would make sure that like you had opted into this next generation beta. And then eventually we like switched it, and then you have to kind of opt out. And yeah. And then the next step is going to be, of course, we're going to remove the opt out, and then people that, people are going to have to migrate to the next gen fully.
Yep, gotcha. And okay, so you mentioned like it's only at first it was only compatible with a few runtimes. I guess like what did that look like? Do you have to write sort of custom instrumentation for every runtime, or like how does that even work with all these different runtimes, and especially bring your own runtime? Like what does that look like to actually write that instrumentation?
That has been the joy of my career these last 4 years here at Datadog. Every runtime is a little different. If you have .NET or Java, which are like extremely tuned and managed runtimes, they have profiler hooks, and profiler in the sense of like a tracer. So in .NET, I think it's called the Common Language Runtime Profiler, and that allows you to instrument method calls. And that's like very specific to that language. So our tracing team has a Datadog tracer that adopts that, but as a result, it has like specific needs for the Lambda extension that we didn't build capabilities for first and foremost. It's not just simply shipping ready to be shipped data, and then the extension needs to aggregate it and then ship it. It has actual like it needs information about the encoding supported and the encryption and things like that, and then it kind of sends that data back to the tracer, and then the tracer prepares it in a certain way. So that's true for, I think we had done that for Java, .NET, Go to a lesser extent, but it still had some special kind of handlings that need to happen for it. So we started, I think, with Node and Python, which are obviously very popular runtimes. And as a result, I think there's like more community support. So these different machinations of tracers were able to adapt more easily at that stage. And then we kind of built it out as we went. And I think a big part of it was like finding launch partners, launch customers that wanted to try it for each of these runtimes.
Yeah, absolutely. What about like, talk me through, I don't want to say like the political, but like the organizational aspects of it where...
Oh, it's political. I think that's fair.
Well, yeah. I mean, like, but like, I know like in the post you mentioned how like, hey, I think you're a pretty wise engineer, and you're like, hey, I'm kind of resistant to rewrites, but at some point you became convinced that like, hey, this is actually a good idea to do this in Rust. Who did you have to get on board? Like what kind of process was that like to convince, I don't know how many affected people that like, hey, this actually is a good idea, make that case to them? Did you have a lot of control and autonomy in that on the serverless team, or did you have to convince a lot of outside teams, or what did that look like?
Yeah, it is political. That's a great question. This goes back. So the namesake of the product is called Project Bottle Cap, and that comes from a blog post by Mark Brooker, who's a VP and distinguished engineer at AWS, works on Lambda, worked on Aurora DSQL, a bunch of other things. And he wrote a blog post a couple of years back called The Builder's Guide to Better Mousetraps. And it's all about building the organizational buy-in to pursue large, ambitious projects with like a high chance of failure. And one of the things they talked about was making sure that you compare the scale of the thing you have to the thing you need to build. And the point that Mark brought up was ostensibly a bottling factory that manufactures and bottles like beer at the scale of millions and millions of bottles a day. Does the exact same thing as a bottle capper that you can just take a bottle, put a cap on, and pinch and crimp the bottle. They have the same functionality, but they have vastly different scales. And that's kind of if you have a new problem and you're looking to pursue a rewrite, that's one of the things to consider. And I think that was a big story that we were telling, is that look, we have this fork of the Go agent. We've effectively already created a second binary within it, like actually created a second version of this code base that we've had to go through. So the idea that we have like one shared code base is already sort of a myth, and it's not able to serve our purposes for these various reasons, and our customers are expecting more. And I think that combined with a really good demo, a really good proof of concept, is key to winning the hearts and minds of people that are going to either be stakeholders or be people that are going to be kind of giving you the go ahead to go and do that. So it took a fair amount of discussion, and obviously the company wanted us to explore every path, right, and make sure that we had kind of crossed our T's and dotted our I's. And I think we had done that. And at that point, once we had a really good internal document laying out kind of the vision for Bottle Cap, everyone was really encouraging about it. Once they saw kind of our perspective of, look, our scale is very different, our use case is very different, customer expectations are very different, and the actual deliverable features are very different. So we should just have a different thing for this use case. And that, I think, was able to kind of sell the vision.
Yeah, interesting. How long did you talk about having a interesting demo that like sort of proves that point? How long did you have to spend on just that, of making something workable enough to prove that out without building the entire thing? How far down the road did you have to go there?
Yeah, a demo is worth 1,000 words. If anyone is looking for a career cheat code, I think the two things I offer is always go a level deeper than your peers. Always be willing to like learn the behind the scenes reasons of why something works the way it works. And the second is have a good demo. Have a good do the work to build a proof of concept along with your document. You need to be a good persuasive writer, I think, in large companies to get people to kind of see things from your perspective. But a demo that works, and you could say, and look, here's the cold start time, and it's 40 milliseconds, right? Like that blows people away when you're like, well, we're not going to get a 10x improvement. One thing I liked, you had Sam Lambert, the CEO of PlanetScale, on the podcast pretty recently, and I was listening to the interview on my way to work, and I enjoyed when he talked about building metal, and he said these P99 plunges, these graphs you see where you go from like 600-700 milliseconds, I think they were talking about like a P99 query time, down to like 30 or 3. Those don't come with marginal changes. They come with fundamental rewrites and fundamental rethinking of how things should work and be organized. And I found that to be entirely true in our experience as well. There just isn't a path in performance engineering where you're going to find 100 little 10 millisecond improvements and get that P99 down. You have to fundamentally rethink and design for that use case. And that was key to the fundamental design of the project. Was every single PR that we merged, we benchmarked. Every single PR, even to this day, before we do every single release, we look exactly at that, not only the cold start time, but the runtime duration. Like, do we add overhead? Do we add more overhead when we're shipping data? Do we add additional network bytes? We're testing different compression algorithms as well to ship data back to Datadog. We have a very mature flush strategy, which allows customers to kind of customize it to their use case and also limit the number of just requests leaving the sandbox to the point that's optimal for them. And it's just a huge part of that work is the perspective of performance first at every step of the way. And that's how you get these, you have to hold performance really close to the heart. And that's a feature. It's not, not everyone needs it, but when you do need it, the only way to get it is to take a microscope at every step of the way.
Yep. That was like one of my favorite parts of that. I guess like, what were you using to even measure all those different things to make sure, hey, on every pull request we don't do, like, what does that look like for someone that has not done that deep of performance work before?
Well, we use Datadog.
Yeah, there we go. There's a pitch. This episode sponsored by Data. No, I'm just kidding. No.
No. It's true. It's true. We Datadog has this whole suite of observability and performance tools, and one thing that we used heavily was the native profiler. And if you haven't used a profiler like a CPU or memory profiler, you should absolutely try it. Pick one. I don't care which one. But I love hearing stories about people who have been experimenting with profilers and found bugs in their programs. And that's a big challenge in Lambda. We have profilers that work in every major language and runtime for Lambda. But if you want to profile a binary, a fully native compiled binary, that's actually really hard in Lambda because the system calls, specifically perf event open, are blocked by Firecracker. So what I did was I rebuilt Lambda on top of EC2, and I used the Lambda runtime interface emulator, and then I wrote a kind of a custom layer for Lambda's telemetry API. And then I created these like hell tests where this function would allocate massive strings and then send them to the extension, or create many spans or huge amounts of metric contexts or metrics and push them through the pipe. So what I did was I created these hell programs, these hell Lambda functions that would push the extension to the limit. And then every time we were testing a major change, and what comes to mind is we were using hardware threads when we started the program, and we didn't want to use Toke.io. Or
wait, you were using what?
Let me back up.
Okay.
So I built this profiler on top. I built this EC2 instance that used Datadog's native profiler to profile BottleCap in its normal like Lambda extension mode. And I ran it kind of outside of Docker because I needed access to these system calls, and I ran it outside of Lambda's. I ran it outside of Firecrackers because I needed access to these system calls, and then I kind of recreated Lambda. And from there, I created all of these like test cases that I could run the program through before we shipped big changes. And one simple example was when we started the project, it was a Rust project using native threads or hardware threads. And so we weren't using any custom, like Toke.io is the popular asynchronous runtime. It gives you features similar to what you would get in like Node.js, where you can kind of async and await. Those features are now built into Rust, but Toke.io kind of had them first and was out first. And it's like very well supported. The whole kind of most of the libraries you use in Rust are going to be Toke.io compatible. And when we added that, we wanted to be very sure it was a net win. So we were profiling it on these various CPU sizes, various memory sizes, and making sure that it wasn't causing us to bog down. And only when we were able to kind of prove that with a profiler and show that the runtime wasn't spending unnecessary time, like moving tasks around threads or that sort of thing, then we were comfortable releasing it.
Release. When you say release it, like bringing Toke.io in, is that what you're saying?
Correct.
Gotcha. So you wrote it originally without Toke.io, sort of native stuff, built this performance baseline, and then you're like, hey, bring this in, see if it makes any changes. It does not. We're fine here.
Yeah, and that's still kind of a fluid thing because the efficacy of Toke.io is going to kind of vary depending on the number of vCPUs you provision your Lambda function. So in some cases, it's better probably to have hardware threads and then just have it like dispatch a different thread for everything when you have extra CPU overhead. But especially if you're running in those 128 megabyte Lambda functions, those really tiny ones with an eighth of a vCPU per second or whatever, then Toke.io becomes really helpful because it's able to kind of swap stuff out when needed.
Yeah, interesting. Had you written any Rust before going on this project?
No, not a line. And I think that's a big part of why I was so resistant.
Not a line. That's amazing. Yeah.
Yeah. Languages in general, I think once you really learn and know one, it's easy. I think, in my opinion, it's been easy enough to kind of pick up a second and a third with time. I think this has been a really fun time because LLMs became very popular. So like we had access to like Copilot and ChatGPT, and that became super useful because I had a Go program that worked kind of, and I was able to like copy and paste like 1,000 lines of Go and say, can you just give me Rust from this? Can you like convert this? And I think specifically it helped a lot for custom deserializing of like options and configuration files, which can get really complicated. And that has been like a super useful tool, especially for early career engineers who've kind of like joined the project and were a little intimidated. An LLM is like a really great way to get a quick answer for a question of like, is this correct? Rust also has an incredibly good compiler. So in your editor, it will kind of just beat you over the head until the program is correct. And I think that was also really useful because that combined with an LLM, you can generally, even without a lot of experience, produce technically correct software using that.
Yep. Interesting. Okay, you mentioned that like picking up, like once you know a language, you can pick up other ones. And I think of you as like a Rubyist first, right? Is that right? And then like when you joined at Serverless, like a lot of JavaScript type stuff. Had you done before going to Datadog? Had you done any like, more compiled, like very strongly typed languages?
I've written a little bit of C++ previously, and I have kind of recurring nightmares from it.
Okay.
But I think my first kind of large experience with like distributed systems was with serverless's like backend Lambda functions written in Go, and that was kind of my first. I wouldn't even call that systems programming, and I wouldn't even call like a Lambda extension systems programming. You just use some of the same systems programming techniques and approaches to, we're not building a database here, but we do want safety, and we do want to make sure we're using the correct locking mechanisms, and we're not spending too much time waiting for a mutex, for example. So those principles still apply. But yeah, I spent a lot of time reading books and trying out programs, and both Go and Rust have really good benchmarking, like micro benchmarking tools. So if you have like 12 lines of code and you want to say like, is this better than that? It'll give you this whole spectrum of tests. I mean, like Go Bench, I think is the benchmark standard for that tool. But it's great. It's built into the language, and it makes it really, really easy to test. And Rust has similar tools, and you're able to like really compare, like, is program A or program B better? And those types of things, all performance work is about preserving the win you have and not giving up too much latency, because that's every line of code is like giving up a little bit. And you need to be very, very careful about adding new software on top of existing software without potentially blowing your performance SLAs. So it makes it like, it's really important to create those like micro benchmarks on each PR or on each, even like as I'm working, it's like, am I going to allocate additional strings for this? Is this structure going to escape to the heap? All of those types of things, which to your point, no, I had not had a ton of experience with until this project.
Yeah. I never think about allocating strings in JavaScript. So,
Well, the runtime handles it for you, right? And the same for like the lifetime of a string. Like, how long will this string live? And does it need to be passed around, or is it mutable or not mutable? I think some of those are starting to, I shouldn't say starting. Const has been a thing in JavaScript for a long time. And especially like as TypeScript has kind of taken over the ideas around immutability and state. I think we learned from React and Redux, and we have these like kind of more functional processes that go into our thinking nowadays. And I think a lot of those are just exposed for you bare with Rust. It's like, you want this string to be usable over here? Well, now you have to copy it. And so every time you see clone, you're like, oh, now I'm going to be doing a mem copy. Do I really want to do that?
Yep. Interesting. Yeah. What did you think of the Rust ecosystem? Are there like big gaps there? Does it feel like pretty full featured and fleshed out? How did that feel?
That has been tough, if I'm totally honest. Go has an army of very talented developers led by Rob Pike at Google, and every tiny corner of...
Is he still working on Go at Google? I can't remember.
I'm not actually sure.
Okay.
But the language is mature enough.
Yeah, for sure. Yeah.
And it's clear, like it's there's an army of people working on it. I think the Rust was a project, I believe, started by Mozilla. I know Amazon has a lot of Rust developers and have like core people working on the language there. But I don't think it has the full oomph of like, okay, Google is going to spend, $300 million a year on this language until it's perfect. And I found Go, any single, we wanted to use Unix domain sockets. Go has them perfectly implemented, and the interface works, and it works with every abstraction. So you want to run a web server with a Unix domain socket, it is like 12 lines of code. And with Rust, it's like, you need a couple of these crates, and you got to kind of tie them together, and then you might be on this older version. So it is more difficult. That's for sure. There were many times I wish that I had like the ecosystem of Go. But I think all that said, Rust is pretty mature. There's a lot of support, and you are going to probably spend more time reading library code than you were expecting. I don't think that's a bad thing. You pick up a lot of the patterns and a lot of the idiomatic strategies that you're going to want to use anyway. So, but it is different. I think it is harder than Go.
Yep, interesting. Is Rust like mature as a runtime? Like, are they still like changing stuff version to version, or is it pretty stable and mature that way?
It's extremely stable.
Will they have like a Go 1 to 2 type thing, or like where are they at there?
They could, and I think that would be definitely a battle. I don't expect it to change that much. I think due to the more limited nature, the runtime doesn't handle that much for you. not really in the grand scheme of things. Like, you have to do your own memory management. So there's less surface area for them to break. But of course, like, that can always change. So.
Yep. Okay. Last thing on this, the agent thing. You mentioned like you were writing your own AWS API calls rather than like using the SDK. Tell me about like the decision to go into that and what's going on there.
That came out of a benchmark. It was quite simple. So for context, the Lambda extension can decrypt secrets for Datadog's API, and it uses a couple of different things. It can use Secrets Manager. It can use like KMS. You can give it an encrypted string and tell it to decrypt it with KMS. And to do that, you have to then make those API calls to AWS's either Secrets Manager or KMS or what have you. And to do that, you typically would use the AWS SDK. And we imported it, and we found immediately it was our largest crate, or like the largest dependency we had by far, was the SDK. And it had impacted something like 10 or 20 milliseconds of cold start time, if my memory serves. I want to be clear that there are great people working on this at AWS. They probably improved that, and maybe it's worth looking at again. But at the time for us, when we were testing this, a year ago in March and April, we just found that it was kind of an unacceptable hit. So instead, we wrote our own. Now the making these API calls is pretty straightforward in a sense. They're old like SOAP APIs, so they have pass the arguments you want in the header, and you then sign those headers with this AWS SIG v4 or SIG v4a, which is the newer version, and then you can make the request. So we had kind of just recreated that ourselves. We did have some issues with it here and there. I think I had not initially added support for something like I had not initially added support for Java Snap Start because the credentials can expire because they are stored in the snapshot. There is like a separate endpoint to check out temporary credentials. So I sort of had to like add that on top of things later. But for the most part, we've been pretty happy with that decision. And the biggest reason is we needed 2 API calls and we didn't need the entire SDK.
And so is that just like a function of, you have different requirements than the AWS SDK team has where they need to support everything. And because of that, they have to make some different choices, and like a little bit of latency and size is acceptable for them. Whereas like, you don't need that much and it's easier to do it yourself.
Yeah. Ultimately, the AWS SDK is optimized for Amazon to push versions out for every language with the exact same version. So they use something called Smithy to generate their SDKs. And I mean, JavaScript developers remember going from AWS SDK v2 to v3. I think Java developers remember v1 to v2. Like there's one for every language, and it's been painful. And they're simply not as performant as hand created bespoke SDKs from every language. But Amazon, I think, really wanted a way to have, an automated release. They could kind of write a bunch of metadata and then push this release out for everybody. And it would be the same for every runtime. And that was the priority. So for us, it's just, we have different priorities. And I think...
Interesting. Go ahead.
I was going to say, I think you'll find a lot of agreement with different people who talk about why do we pull in so many dependencies, just take the parts you need. I think that's kind of a growing chorus in the software world these days, which is stop just grabbing random node libraries or Rust crates or, Go packages, like just take the little bit you need and go from there. And I think that's kind of a part of the ethos we took forward was like, we really just need this slice and we don't really need the 10 or 20 millisecond hit, especially because not all users use those API key storage mechanisms, right? Like some people, uploaded it with an environment variable, which are encrypted at rest, or chose other options, and as a result, they didn't need this, and we didn't want them to kind of pay the overhead as well.
Yeah, interesting. Were LLMs useful at generating that particular code? Do you remember?
I think that is yes, because kind of like a Rust compiler when you're dealing with signing a request with AWS SIG4 and kind of making the request, it only works if everything's perfect. So you don't have these failure modes where there's like subtle bugs or performance implications of issues, typically because it either all fails or all works. And I think that's where that became useful. I don't remember that being that helpful for that portion, but I do, like I said, I think I remember LLMs were most helpful when we were parsing large config files and we needed to write custom deserializers for this Rust library called Seerday, which stands for serializer deserializer, and those get a little gritty.
Well, hairy.
And there's also a lot of examples of it. So LLMs became like a really natural fit.
Yep. I had a similar, like the reason I asked about the LLM is I had something similar recently where I'm receiving emails on Amazon SES, and you can choose to have those encrypted when they come in and put them to S3. And if you do that, they encrypt the client side with like the S3 encryption client is what it's called. And then you decrypt it with that, but they only have the S3 encryption client for like 6 languages, and JavaScript is not one of them. And it's like, I didn't want to have a like one other, function in Go or something like that that's using that. So I just like went to the Go library. I found out which sort of encryption algorithm they were using. I went to the Go library and I said, make this, but JavaScript. LLM just made the whole thing, and you test it and it works, and yeah, good to go. So it's like,
see, and that's like a great example of going a level deeper on a problem, right? Because like a number of people would either just give up there, or they would maybe they would like add a sub process or like call out to a C program or like a binary and make it do the work. And instead you're like, well, I'm just going to read the code and then I'm going to figure out how to generate it myself. And yeah, of course, like the LLM helped you, but I think I'm very much on the page of like, it's helping me go faster. It's not like totally making me see things in a new way necessarily. It's at its best. I think these tools, including Claude Code and Copilot, are at their best when you give them a very specific direction. You kind of know the shape of the answer you want. But I do find it very useful, and we did use it heavily throughout this process. So that was a lot of fun.
Yep. And it's like something that's like, yeah, you could do it. It would take you a lot more time, to the point where it's like, maybe I wouldn't do it, and just because I'm like so annoyed and I have like other higher priorities. But now it's like, yeah, like it can do it a lot faster, and you can see if it works. So
I think it's changing customer expectations too. I think the next 10 years of software companies are going to be expected to provide pretty bespoke custom solutions for every customer, because the barrier to modify or maintain that software is sort of coming down. And I think as a result, these types of projects like BottleCap, where you have like this purpose-built thing for the specific niche, are going to just grow. Like that's the expectation, is that this thing should be as minimal as can be across in any dimension we care about. It needs to be kind of bespoke for that. And that's kind of tough, because SaaS businesses were created around this guise of well, you'll write the software once and you sell it over and over again with zero additional marginal cost of goods sold. And I think that is going to start to change a little bit. But as a result, you'll be able to sell into customers that previously wouldn't have considered your product. Like for us, like we had painful cold starts, and there were certain customers that were just like, we can't touch this as a result. And now we're able to get them back. I mean, people replied to the blog post and said like, we had considered this. And we ruled it out early on, but now with this new performance improvement, we signed up, and yeah, it's been great.
Yep, that's awesome. Tell me more about the bespoke software stuff. Like, do you think we'll see that in this is like a developer tool, which is like one sort of thing where we're sort of used to using LLMs or we know our specific requirements quite well and evaluate those things. I guess, like, do you see a lot of bespoke software happening in B2B SaaS or prosumer or even consumer type stuff? Like, do you think software is going to be like pretty bespoke across the board for like all types of consumers going forward?
Yeah, I do think so. I mean, obviously, like the beating heart of systems, like the back-end distributed systems, are going to be limited in what they can necessarily adapt to or clone. Although I do think the cost of running software is approaching a commodity price, right? Like these managed services are getting close to like the limit of what you can really do in a general sense. But I do think that as far as like people using your libraries or interacting with your APIs, there's going to be this expectation of it being pretty highly customized. Now, whether that happens on your end, on the API level, or via, like a model context protocol kind of interacting where an agent on their end takes your API, consumes it, and modifies it in the way the customer wants, I'm not sure. I think it's going to be a little bit of both. But I do think kind of the age of like, oh, you want to interact with Stripe, and here's their crazy. Well, Stripe is a great API,
but getting harder, I would say.
But maybe you want to interact with a payment processor like Zora.
Yeah, Zora's worse.
Yeah, here's this giant SOAP library, and you're going to have to like pull all these dependencies in, and it's going to be a big challenge. And I think that era is coming to an end, which is probably going to be a good thing. I do think it's going to create more demand for software, because as kind of the price falls, the demand curve is going to shift out, and people are going to want more of it.
Yep. Yeah. I know the interesting thing is like, I think we can create software a lot faster. It's hard for me to imagine like a world with 100 times or 1,000 times as much software as we have now. But I think that is like coming. I can't really picture what that's going to look like. But yeah, I think it's going to be pretty wild.
I mean, I do think it'll be the dimension of kind of personal software is one aspect of that, where you're going to be able to customize, apps on your phone or on your computers a little bit better. the journey, if you've watched or you've experimented with any of the like homebrew labs or like home hosted solutions, has come a really long way. The different toolkits for starting up your own web server or running a server on a bare metal box in your basement have gotten way better. I'm thinking about things like Tailscale, which have just been incredible, where if you wanted to create your own VPN previously, you have to deal with like OpenVPN and all these very kind of challenging tools to set up and run. And now it's just 2 OAuth clicks, one on your phone and one on your home server, and then you can connect securely anywhere in the world. And those types of things are laying the groundwork for like, oh, I want to plug this into that, and that's only relevant for your workflow, but it's going to be something you're going to be able to do. So I do think 100x more software maybe isn't the right way I think about it. I think about it more of like if you compare binaries of software between each other, there's going to be 80% variance versus previously it was like configurable and it was like a very rigid.
Yep. Interesting. I guess so. On that same point of AI usage, like how are you using AI day to day? I think there's like a broad spectrum of like Copilot Tab Complete. There's Cursor more agent mode. There's Claude Code. I guess like what are you sort of using day to day?
I'm trying it all. I'm just trying to stay super curious. Again, like my big ethos is like kind of try everything and go a level deeper on everything. So my main workflow is still, I can't get out of Vim. I'm still on NeoVim. I've been a Vim user for a couple of decades, and I just everything feels slow. Once Vim motions, everything feels slow. So I use VS Code for a little bit. I do have Cursor. I have used Cursor. There's a version of a Cursor-like experience called Avante for NeoVim that I'm really pleased with. I'm having a lot of fun. I also like Claude Code a lot. That's been a very cool tool. It allows me to chat back and forth with it. I think, like all developers, the things I really wish it could do, it just falls down at, where it's they're really hard. Like I would love to point it at BottleCap and say, write a PR that drives the number of mem copies to minimum. Like whatever it is, however many times you have to copy the string, make it as little as possible, and introduce lifetimes. And if you need to, static lifetimes or even like a memory arena to hold some data. And like we haven't had to do that yet, but obviously if you throw that at an LLM, it totally crashes and burns right now.
Yeah. Oh yeah, for sure. Like that sort of hard thing. I'll be curious like when that becomes truly doable. But like right now I like a few like full stack apps I'm helping with, and that it's just like like you have these patterns. So it's like, hey, go make this new data access pattern. Now write the route for it. Now write like the front end service to consume it. Now write the like display logic, and it can just do that so easily once you have like a few patterns in your application. It's just like, just it's not super hard code, but it does save you a lot of time and like doesn't drain you from the monotony of that sort of stuff, which is fun.
I do think it's been an absolute boon for application, like web application development, and I think a big part of that is just like training data set. Is a much larger component. But at the same time, it's clear that it doesn't quite have if you have two pieces of software, it has a very hard time telling you, is this better than that? Yes or no. And as a result, it's sort of regressing to the mean of the average GitHub push, which I would love to see that kind of improve. I'm not sure. I don't have enough of an ML background to tell you how that's going to work. But for the cases where like for example, I had a Go file that created tags for metadata depending on different runtime attributes, and I just was like, "Can you make this Rust, please?" And it basically one-shot it. Now at the same time, I just yesterday I fixed a bug where I used the LLM to parse a YAML file, and it inadvertently broke an environment variable, and I didn't know it. And like it was my own gap. I didn't have a test for it, but the LLM was like, "Oh no, this is it. This is all you need." And I tried it, and it worked. So I it's like, okay, we'll do this, and then I get a bug report, and sure enough, it turns out like, oh, this no longer processes the environment variable version of this correctly, and it needs to, and it's just. Yeah. So
it is hard because like you start to trust it. You're like, man, it nailed that last thing. This seems pretty similar, like in that same wheelhouse. Like I'm sure it'll do it. And it's like you scan it over, but you're not looking quite as closely as you can. So it's like you got to figure out, test coverage / eyeballing / manual clicking around, like what you sort of need for it. And based on your level of seriousness for like how important it is, if there is an error and things like that, it's going to vary. So
at the risk of sounding too old, I think it's a boon for early career software developers because you basically get a mid-senior engineer with unlimited patience that you can just ask questions to. And I think for me, I was always getting the feedback that I was like too needy early on in my career and like asking for help too much and not spending enough time, trying to run things down myself. And I think the LLM is like such a great tool for that. But you do still get, I mean, I'm sure you've experienced this, and I think everybody has, where it gets caught in a loop where it can't, the initial approach it chose wasn't correct for whatever reason. And maybe it was my fault. I didn't give it enough context. But then it runs down an unsustainable path where it's like deleting code or, leaving methods around and that sort of thing. And I think that we're just not there yet, but it is a really exciting time and I'm enjoying it. And I don't really think it's going to bring about like mass unemployment. I think it's just going to create kind of more demand for software.
Yep. So you're not in the AI 2027 camp?
I guess I don't have enough information to make that decision if we're being totally pragmatic. I think it's obviously a possibility, especially if it gets to the point where it can do all versions of independent thought independently, then of course, yeah, that's going to change my opinion on it. I just, all of the companies that are working on this technology that are out there are expanding. They're taking what they have, like the models they have, and they're deploying them in different modalities and different, integrations and that sort of thing. They're not saying, okay, we have like 20 years of advancements ready for you next week, right? And that's sort of where I'm starting to indicate that we may be unable to solve some of these really core problems, but that doesn't mean the tool is useless. It's super useful.
Yeah, it's super. Yeah, I completely agree. Okay, I want to switch and do some AWS infra takes, because I think AWS/infra takes a lot of AWS stuff, but I feel like you always have some good stuff on that. So first of all, I have a few that I've heard from you before, but I want to just hear you defend it publicly. Number one, you're like a big fan of App Runner, right? You're like one of the two people that loves App Runner. I guess, you and Jeremy Daly and like Chris Munns, those are like the three that I think of for it. So like, I guess, are you still there? And if so, sell me on it.
I can't recommend that anyone use App Runner anymore, because I think, just as evidenced by the entire lack of changes in the last 5 years, I don't think they're working on it. I don't have any special information to indicate that, but that's just my gut feeling on it. So I don't want anyone to wake up tomorrow and they're like, oh, it's going to go into life. Like, you have to move everything again.
What did you love about it?
Oh man, I think Amazon was able to somehow solve a two-pizza team problem for the first time in the history of the company. And they were like, we're going to solve this problem vertically end to end. And it was a really cool experience. If you hadn't used App Runner, it gave you this really managed experience where you could connect it straight to GitHub. It would build a container out of your application, and then it would run it as a managed container service. So more similar to Fargate, where you have kind of a long running container, but it could scale up for you. It could scale down for you. It could like turn it off. It never really scaled to zero super well, but it had, it was like mostly there. They couldn't figure out the cogs, and they kind of didn't know how to make the next step. And I believe a big part of that is Amazon deals with such crazy large enterprise customers where they're like, okay, we want this experience, but for Java 8, and we need it to be like compatible with this like SOC 2 or like bank regulations or whatever, and all these different hard problems to solve where they weren't quite sure the addressable market was there. Whereas a company like a Vercel or a Railway, or a Fly.io can kind of just take the easiest path and kind of ignore some of those really hard problems. I think Amazon, it's very difficult organizationally to do that there. And so I think I'm kind of lamenting the end of it. Although I did notice they've been starting to push a bunch of changes to Elastic Beanstalk for the first time in like a decade. So yeah, maybe that's the future again. What's old is new. But yeah, I thought App Runner was a really good crack at something. And I think the product was good. It was fun to use. They had a bunch of, they had that intractable problems that they had to solve. For example, if your application failed a health check, it would roll back to the previous version, but it wouldn't roll back your CloudFormation deploy. So it wasn't like the full feature you get from Lambda, where like if the Lambda function doesn't start or something, you at least like get some indication on CloudFormation, and it just didn't do that for App Runner. And there's like a number of cases of that where things kind of languished and they weren't able to solve it, unfortunately. Yeah.
I think sort of on this note, one of my biggest complaints about AWS is it can be really hard to know which services are like soft deprecated, or like like set up for deprecation. And it's like, of course they can't come out and say but it's like, man, like you're trying to make decisions on what things to invest in, and it's hard to know what they're investing in, and it's nice in some sense that they're starting to deprecate some stuff and be a little more clear on that. But even like, yeah, you have to like read the tea leaves and try and figure out, oh man, they haven't done any updates for App Runner in a long time. There's might not be a team there.
Well, not even that. Like
yeah.
AppRunner has gotten so bad that the creator of Java, who was a distinguished engineer at Amazon, flamed the AppRunner team in a GitHub issue and said, "You're on Java, like I think it was 17 or something. Like, why are you so far behind? Why is this project so far behind?" And this is the guy that wrote Java. So then I think that's a pretty strong. I think that's a pretty strong tip. But yeah, I agree. You do have to kind of read the tea leaves, and like everything in life, if you go with the flow, it's a little easier for you. So you're going to find more success on, EKS or ECS or Lambda than you are on like an app runner. So I think, write a container, use a container-based Lambda function. When you're outscaling that, move it to Fargate, and then be happy.
That was my next question. Same thing with container images over zip files. You've been team container for a while now.
And I've been right.
Tell me, yeah. Tell me why. Tell me why I shouldn't use a zip.
Yeah, I mean, it's just clear that container, the Open Container Initiative and OCI standard has become the standard for packaging applications. It's true that it's objectively it's true that containers are objectively worse packaging mechanisms than zip files. The idea of a zip, and it's a beautiful idea, and I think it's pure in an academic sense. So if you want me to defend the Lambda zip-based function, the reason is you zip up exactly only the bits you need. Only the tiny components you need and the dependencies you need, and then Lambda provides the rest. And as a result, they're able to cache those base images really, really well. So you get faster cold starts for the bits there than you maybe would have provided, and so on and so forth. The problem is people get it wrong all the time. I see people screw up their zip functions all the time. There are test dependencies, there's JSON files, there's movies in there accidentally, something that was just in the directory. And they're like, why is my function too large? It's like, well, you've got like a copy of, I don't know, like Elf in here for some reason. So that's one aspect of it. And I think containers, while people still are confused by them and make elementary mistakes with them, the odds are you could find a developer on the street and hire them, and they'll know how a container works. And I think that is just the simple fact that they've kind of won the packaging war in the cloud ecosystem. And as a result, it's easier to just kind of go with the flow there. Lambda also put in a ton of work to make them really fast. I did a blog post and a video about it when I benchmarked it, but they do something really cool. Every time you deploy a container-based Lambda function, Lambda will go to Elastic Container Registry. It'll pull the container, and then it will create a hash of each 512 kilobyte chunk in your container image, and then it will look and compare and see if it's already seen those chunks. And if it has, it just drops them. And then it creates a manifest file for your Lambda function, and then it creates keys based on each of those chunks that are specific to your function, and then it creates kind of a main key that encrypts all of the keys for all of the chunks, and it stores that. Then when you have a cold start, when it has to bootstrap a new Lambda sandbox, it goes out and it uses this concept of content addressable keys, where it says, okay, find me all of these chunks based on this hash. And the only way that you can decrypt all of those chunks is with that, primary key, that main key that encrypted all of the other keys that are used for each of those 512 kilobyte chunks. So that means that if you and I have the same, chunk of a container, we can just reuse it and we can share it. And that means that those are often for very rudimentary systems or rudimentary files. Those are probably already cached out there somewhere. So you're able to just have really, really fast cold starts, even though they support up to 10 gigabyte images, which compared to a 250 megabyte Lambda function is a nice win.
Yep. Yeah. Definitely check out AWS write-up and video on that, and like the original stuff by Mark. But like that whole thing, like Mark's stuff on it, the way you explained it, that was like one of those things where it's like, man, the AWS people have to think of things at like just like a completely different level than what I ever have to think about. And it's like super fun to read all those things. And also realize like, man, I don't have to deal with that stuff, which is nice.
You just get to benefit from it.
Yeah. Yep.
Yeah. And now you can just use a container-based Lambda function, and it's as fast or faster as the zip function, and it's easier to develop. You get more consistent, reproducible builds. You don't have to worry about these crazy bash scripts that have to run on your MacBook and like cross-compile or any of that. All of it just works right now, and I think that's the benefit.
Yep. Okay, next question. This is on AWS. What is a more annoying problem? That there's not a way to sort of like enforce the free tier, or where it's just like, hey, I don't want to spend any money on this, so I want this to be like a free account, so because you sometimes see those people that like they're a student, they get like a $3,000 bill. That one, the free tier problem. Or what I call like the new production account problem, where when you create a new account, you have to request like Lambda limit increases because you get like 10 concurrent functions, or like to get out of SES sandbox mode is like a total pain in the butt, or SMS sandbox mode, and like all these like permission things that you have to go through just to like get through basic stuff. Which of those is more annoying?
Oh, I wish both. Can I press the button for both?
Yeah.
The free tier billing thing is such a miss on their end, but it's just not meant for students. I think the if every time someone says like, oh, I got this huge bill, it's like, I'm sorry. Like, there are ways to avoid it, but it's just not designed. The entire system is not designed for you. It's an enterprise platform, unfortunately. So the recommendations that I always have is just set the account limit, set the billing limit, and then guard those keys, or don't use any access keys. Use SSO, and then you can kind of avoid the like it leaked and now someone's mining crypto with all my credits. I think that problem does like the reason they do that is to prevent the second problem. Or the reason they do the second problem is to prevent the first problem, which is, if they gave everybody uncapped accounts all the time, the abuse would be rampant. So that's why they lock it down. I do think if I were to start a consultancy around this, I know the magic words to talk to SES and get them to lift the limit and get you out of sandbox mode. I know the same for Lambda and all those kind of places you're going to run into it. That is tough. I wish that when you're using an Amazon organizational unit, an OU, when you create a new account within that organization, they just give you limits from like a predefined set that are allowed for your org. I think that would be really, really nice.
Yeah. Or if you could like pre-verify an account in some way and just like, I don't know, have a check, like validate your bank account or something like that. Something that would be hard for, like truly a bad actor that's just going to come in and like steal compute and leave.
The truth is that like even for the students that are getting these bills, or people like you and I that want to spend say $100 a month on Amazon, like it's not designed for that either, right? It's the actual value you get out of Amazon and AWS is when you're on these commit spend accounts where you're going to commit to spend millions of dollars a month, and from there you can kind of pick whatever compute you need and those types of things, and that's when you really get the actual full feeling of what an AWS account can do, and that's it has to work at that scale, and I think as a result, because that's where the revenue is, that's sort of where it's optimized for. It's unfortunate. There's people in the community doing great work to try and help everyone avoid those sharp edges. I think I count you in that group, but it is tough, and I don't know how you solve that problem, because the scale at which Amazon can give you compute and thus bill you is so fast that it's very, very difficult to say, okay, now you have this limit. I would say there's an educational account available for students where it's very limited what you can do, but you don't even type a credit card in. It's like you.
Oh, that's interesting. I didn't know about that. That's cool.
Yeah, but it is very, very limited. So it's like it's a learning path system.
This the second issue is like my hobby horse right now, because I was like helping set up a new account recently, and like it took me multiple emails just to get out of SES sandbox mode. And I'm like, no, I'm just sending transactional emails.
Yeah, not marketing emails.
It's like, this is exactly in the way. Yeah, it's like, come on, give me a break. So, okay, next one, AWS network costs. I think you've been you are like one of the biggest opponents, or like one of the people that I think of that says like, these are total bunk. I think they actually have some validity to them. I guess like, tell me what you think on AWS network costs. And I'm mostly talking inter AZ costs, also egress costs. They charge you a couple cents to get out. Like,
yeah, per gigabyte. It's not cheap. I forget all the numbers, and it will change, so I don't want to misquote it. But it's crazy how fast that becomes your highest bill line item. You can spend millions of dollars a month on AWS, and then all of a sudden, EC2 networking is your number one bill. And I think that there are some valid points. I mean, it's a limited resource, and it's sort of a public good. So you have to defend against the tragedy of the commons, where people would send bits everywhere, and they would do so in a way that maybe you didn't need to do. But I do have some complaints. And the simple one is former Datadog employees left to start a company called WarpStream, and their whole premise is, we're going to give you a binary compatible Kafka deployment, and it'll be backed by S3. Why S3? Well, it's quite a bit slower. Your Kafka writes and reads could be single-digit milliseconds before, and now they're going to be hundreds of milliseconds or even seconds. But S3 replicates data across AZs for free. It's built into the cost of it, and they were able to realize something like a 10 or 20x cost improvement on Kafka running Kafka backed by S3. So that tells me that it can't be that networking costs can't be so much of a hit because you're able to do that and save so much money, and it's built into the price of S3, which is already a commodity product. So it's very clear to me that like you and I are paying much more bandwidth rate than like the S3 team pays. So now we have all these cases where it's like, they can sell their company for $220 million because they found this kind of cheat in the bandwidth billing. Like that's truly and really at its core what it is. And good for them. I'm very, both those guys, Ryan and Richie, I know they've been on your podcast, and I really appreciated talking with them over the years. I think they're really sharp people.
Yeah, they're sharp. They're smart guys. Yeah.
But it is exploiting the billing model, and they should. It's a good thing, and I want more people to do that. And I think more data systems are going to do that kind of thing. But
my question on that, and I'm like, I think that's the strongest point against my argument is like what's going on with S3 there, and I don't know if that's like a billing mistake that they are locked into now, like they sort of mispriced that in some way and didn't account for that very well, or if they are just or. I think there's sort of three possibilities. It's a billing mistake. The second one is like actually inter-AZ networking does not cost that much or is not that scarce, and like they're overcharging for it. And the third one is like, hey, there's some efficiencies that the S3 team is able to do, or some amount of predictability or something there, as compared to just like the fact that if I just want to come in and throw a bunch of traffic at it that they can't account for and things like that, they need to have like a different rate for that sort of thing. So
yeah. I mean, so it's a combination of 2 and 3. I don't really think it's 1. And I think the 2 is it's a high margin for them. And when they already, especially within an availability zone, they've already talked about, they've given talks. AWS has given talks like Cole McCarthy and another. I forget the person's name. There was this great talk at Riemann about the hollow core fiber they were using between AZs in US East 1. So they were able to actually get like double the range that the buildings could be away from each other. As a result, they're able to just buy more real estate and have more capacity in US East 1. And that tells me that they're able to, once they have the trench dug for the fiber, running huge backhaul cables, like massive links that are doing, hundreds and hundreds of gigabits per second across many redundant links are very cheap for them to add. So I don't think that bandwidth is too saturated, but because those links, they operate on like peak bandwidth, I think you could build for whatever your peak is, or I shouldn't say that. They have to account for the peak of transmission between two AZs, two physical buildings. It becomes a very big opportunity to optimize when you can like do things off peak. So I'm thinking like elastic block storage, EBS snapshot replication is pretty cheap. It's actually, I think it can be cheaper than S3. And my guess is they're just replicating it at night where there's not very much load. And as a result, they get like a lower quoted price internally or whatever. So I think there's like opportunity for those types of things. But I do, I don't think those links are super taxed. I'm sure they are at certain times. And the idea is we don't want people to abuse that. I get that. But for things like Kafka, where like best practice is to use multi-AZ, it kind of sucks because you're just going to pay this huge tax.
Yep. Yeah. I think that.
And I would say the last point I would add is like other clouds don't bill for that. So it's really hard for me to make the point.
Well, okay. So Google does, right?
Google does.
Microsoft says they do, but they don't, which is weird, I think.
Yep. And Oracle doesn't at all.
Oracle's trying to catch up in some sense. So it's like,
yeah, of course.
And then Cloudflare has this like whole game. They're like, we don't, but then once you get big enough, they do, is what it sounds like, which is like what they get a little kind of pious sounding on that sort of thing. And I don't know like what the story is. They also just like have a very different traffic profile than AWS does. I think like given all the ingress stuff, it's just like a different. I think it reminds me of the strategy credit that Ben Thompson and Stratechery talks about, where like sometimes just because of like who your customer is or the shape of your product, you can sort of like claim some things that are actually much cheaper for you than for everyone else. And you can sort of like position it as like this value, or like we're doing it out of good.
Yeah, arbitrage that.
Yeah, we're doing it out of the goodness of our heart, or because we really believe in this. But it's like actually it's just like a lot cheaper for you than for someone else. So it's like a talking point or an argument you can use as a sword against them. And yeah, so I feel like I really want to get to the ground of like what's going on with Cloudflare there, because they talk one game and then it sounds like the reality is like a little bit different on some of that stuff.
Yeah, I just think that like their business is structured in such a way where they can, like you said, they can kind of use that as a marketing kind of tool against others. I think a similar one would be, they advertise that they only charge you for CPU time. So if you're waiting the result of something on the network, you don't get charged for that in workers. I think that's great, but also for even the largest scale Lambda deployments, Lambda itself is typically not the number one bill item for a serverless application, right? It's S3 or Dynamo or API Gateway or CloudWatch,
SQS or whatever. Yeah.
SQS, yeah, exactly. Like those bills add up. And typically, I think Lambda is like number 3. So sure, that's true. And I think it's an opportunity for Cloudflare to kind of hit AWS with it every chance they get. But if you actually look at like what that would cost you in the end of your day, maybe it's not as much as you'd think.
Yep. Yeah, so I still want to get to the bottom of this. I feel like no one has a great handle on the networking stuff, but the things that I would say are in my favor is Google does actually charge for it. Microsoft says they do. Cloudflare is kind of cagey on it, and then also, I can't remember if you were there. I was talking to someone at reInvent that works on EBS, and he was saying they spend a bunch of time trying to optimize or limit cross AZ stuff. They like a lot of different things like that, and like it is a factor for them. Someone on CloudWatch was saying like, hey, we get billed for network costs and we look at it and think about it. And like, again, like you're saying, they're preventing a tragedy of the commons where if you don't think about that, then you're going to use this inter AZ traffic just willy nilly without like thinking about it. So at least just putting a cost on it makes you think about it and at least consider that trade-off.
Yeah, I think the issue I take with it is I think it's just it started that way as like we just need to make sure people don't abuse it, and it sort of has ended now at this like, oh, we're going to make this our primary margin, and
that's true. It is like a profit center now that they can't like get away. That's a good point.
Yeah, and you can't step back. So I think if you start to see an actual slashing of prices and like competition across clouds in a huge way, I think you'll see that cost start to come down. And if you see them cutting that cost, then it's kind of a strong indicator that it was a big part of their margin.
Yep. Interesting. Okay, so while we're on this point, Cloudflare. Are you using Cloudflare?
I've played with it. I've really been trying to use their container service, and they haven't added me to the beta, and they announced it like a year ago. So I'm a little annoyed there.
Come on, Boris, Michael, somebody get him in there. Yeah.
I'm trying. I'm hoping. I want to try it out. I haven't really used workers because I don't write a lot of JavaScript anymore. So just like kind of adapting to that hasn't been my primary focus. And then, so it hasn't been a huge focus of mine, but I admire their work. I know and respect and have a lot of friends over there. I think they're a really great group, and I think they're kind of going the right direction.
Yep. Yeah, the big thing for me is I'd say like I do like a lot of the people there, very sharp. The concepts are weird, right? Like you really have to change. Like learning Lambda is like different than containers in certain ways or servers in different ways, but it's also like very similar in a lot of ways. Where I feel like workers and durable objects, like they're just like way different than some of the other concepts. You really have to like kind of go all in and understand those sorts of things in a different way. And then still like the surrounding ecosystem around like permissions logging, infrastructure as code is just like not as robust as the other stuff. So that's like what's holding me back on Cloudflare. But I do like the people there and what they're doing. So yeah.
Yeah, I do think they need a better infrastructure as code story. I think that's definitely a big gap. I know SST has been pushing that direction, and I think if that really...
Yeah, they've got some good stuff for it. Yeah.
Yeah, if that cracks it, I think it's kind of going to be a big growth opportunity for them.
Yep, for sure. Okay, last one on infra area, like the database ecosystem. What are you seeing out there? What do you like, excited about? What do you think about it?
Man, I dabble in all, like this is my favorite part of programming right now is like database programming and systems programming. So I've been following Sam Lambert, of course, talking about planet scale metal has been really exciting. I like totally agree with him getting rid of the free tier. I think free tiers are just like a massive cost sink, and they don't really convert super well from my experience, mostly at serverless. I think it's just been like you need incredible margins at scale to be able to subsidize a free tier. And I think that if I'm building a SaaS today, if I'm going to quit and do my own thing, I would do a 2-week trial, and that's it. It's like if you like it, you pay for it. If you don't, you don't.
Get serious or not. Yeah.
Yeah, and it's not like it's just more about who I want to partner with a customer, and not so much like do I want to talk about my user base numbers. I think the growth of users and free tiers became like a talking point for raising money, and that's why you see it's like the dog wagging the tail. That was a metric they could put on the screen and say, look at all these users that we're getting, and but none of them would ever pay for the product. So I think if you want to build something sustainable, and I know Sam talked about that on your podcast, I think that's like a much better route to do. So I think Aurora DSQL is a very interesting piece of technology. Not everybody needs multi-region, and I think that's where Sam would really like kind of butt up against it or has publicly. For people that do need active, it's an incredible piece of technology. I mean, it's just you really not had anything like it that was so easy probably ever, and I think that's a really really cool tool. So if you have that need, it's awesome. If you don't, there's like some rough edges, but if you really just want a relational data store in Lambda, Aurora is pretty awesome. Like you should check out DSQL. And then I follow kind of all of the key value store stuff too. So like we, internally we use Foundation DB quite heavily. That's a kind of very popular. It was nascent and now becoming a popular key value store. And of course, like Dynamo, Cassandra, and so on.
Yep. Yeah, it's interesting on the free tier stuff. It's interesting because you have RDS and Aurora, kind of the elephants in the room. You have Planet Scale Metal, which doesn't have a free tier. Then there's like so many competing for like the rest. And like Supabase is like a pretty big one in that category. And then you have so many other ones. And man, that's just like a tough area to be competing in. I like a lot of those folks and companies and things like that. But that's a tough area to be competing in. It'll be interesting.
It really is. And I think databases in general are like, as much of the apprehension I have around rewriting software, I have around like picking a database provider that's like a third party. So it's a very difficult thing to get right. I don't envy them, but I like the work and I like where people are going with it. The foray into having like a hosted SQLite per customer, like a multi-tenant app, is a very interesting idea, and I think there's value there. These like hosted databases that are like Metal that are doing replication, at the per server level, and they're, I think Sam had said like no node lives more than 29 days. Like those types of things I think are really interesting and compelling too. So I love reading the papers, I love seeing the benchmarks, and I love, of course, the drama. So I do like following it now.
Yeah. And it's interesting seeing like all the OLTP on object storage stuff that's happening, which like I never would have thought would be a thing. And
it's the same reason WarpStream did it. The cost of that storage is so cheap when you're on the cloud. And, if you can get away from EBS, which has a lot of its own challenges, it's like a really big opportunity.
Yeah. I just figured like the latency would just be like sort of unacceptable for it, and like, it was awesome for Snowflake, but that's like a totally different set of needs.
Totally.
So
I mean, the answer is the same, like similar to what we did in BottleCap, right? Where like not everybody needs read after write consistency or even like, serialized snapshot consistency. Maybe they just need, eventual consistency, and that eventuality is like on terms of seconds. And all of a sudden it becomes a very interesting and compelling use case where your costs become maybe from like your number one cloud cost to like a rounding error on your bill. And that's, everything's fungible, man.
Yep. It's true. So I'll be curious because like that's a hard technology problem and a lot of people working on it. I'm sure like some cool stuff is going to shake out of that. I'll be, it's going to take a little while on that, but yeah, some cool stuff there. Closing out here, I want to just talk about like maybe career advice, just because I think your path is so interesting. You were a Rubyist. You had done some deep stuff because you had like done all this Elasticsearch sort of deep dive and gave a talk at reInvent. Came to serverless, did a bunch of JavaScript and some Go, and now like doing the deeper, more system stuff. I guess like what career advice would you, I guess you said the two pieces of career that are at least like
go a level deeper, right?
Yeah, go a level deeper.
No, I could expand on that. If I'm going to give career advice, especially like to myself in the past, like the first is like calm down. It's going to be okay. And that's something I even tell myself now as like a new dad. Calm down. It's going to be okay. And also, everything. At the end of the day, a computer and a CPU are operating on the same principles as your computer and your CPU and so on and so forth, right? So like the server in the cloud and the server on your machine are basically the same. There are some very cool differences like remote direct memory access and, GPU programming and stuff like that. But that aside, your Java, your Ruby, your Go, your Rust, your JavaScript, and Python, they're all making abstractions on top of the same concrete understanding of the actual CPU and architecture. So if you learn a little bit about how that works, it can actually take you a really long way across all languages and kind of all dimensions. So yeah, go a level deeper, learn. And that's true no matter what your niche is. Like learn how HTTP works. Learn, it's a text protocol. You should at some point in your career write an actual HTTP request in a text editor and send it and try it and realize that there's not a magic there. I think it's very common, especially for like early career JavaScript and Python developers to use their libraries and think that is the fundamental abstraction by which they have to approach the world. And then when I showed them a curl command where I'm like, oh, look, I just have this text file and I can tell curl to send it and it's valid because it has headers and then it has a line break and a carriage return. There's two of them, right? And then there's like the body. And now HTTP v2, of course, is a binary and framed protocol. So there's like a little difference, but you build on that. Similar to networking, there's been a discussion of Vercel as being like blocked in Spain because they're blocking La Liga, the Spanish football league, is blocking IP addresses at a wholesale level that are associated with, I guess, illegal reproductions of like football games. And because they're doing this at the IP level and not at the domain level using the server name indicator, which it passes through the feed through the TCP connection when you upgrade to TLS, it blocks anybody that shares an IP. And it's the same reason you were talking about with SES. Like, why is it hard to get out of the email jail? Well, it's very, very difficult to have a good reputation IP address that sends email. So Amazon protects that very closely. And what I'm saying as far as career advice is all of these things relate to the same principles because IP addressing and IP networks make the backbone of what we're all doing. So if you understand a little bit about it, it can actually take you a really long way. So learn how HTTP works, learn how TCP works, learn UDP, like try it out, write your own servers and requests and get down in the nitty gritty. And I think it's just like a huge step forward in your career that you can have compared to peers.
Yep. And one thing you said earlier about like, don't be afraid to dig into the library too, I think is so useful. I know like when I was learning to code, honestly, like what I did is I would answer questions on Stack Overflow in like the Django topic of like things I hadn't done, but like someone would ask a question and I would go like, read the Django docs, read the source code, try and figure out how it worked and like try and explain it to people. And that just like, being able to, that just helped me so much with like reading code and figuring out what's happening and yeah, going a little deeper, I think is like super helpful. So,
yeah, if I could sum it up, I think that's it. And like, it's a brave world out there, brave new world. Don't be scared of the LLMs, like use them. They're very helpful. And for every second you're scared that it's going to unemploy you, you'll find a second where you're like, oh, this is totally falling apart and I can beat this thing. Or I don't know about that, but like I can use this, right? It's a tool.
I can beat the John Henry or whatever that.
Yeah, exactly. Yeah.
Yeah. So
yeah, on the railroad. Yeah.
Yeah, exactly. AJ, always great to talk to you. Thanks for coming on. If people want to find you, what's the easiest place to find you?
I guess for now, you can still find me on Twitter at ASTUIVE. You can send me an email. I'm just AJ@datadoghq.com. You can find me on LinkedIn. You can just search for AJ. I real name post everywhere, including on places like Reddit. I think it just kind of builds your own integrity it builds your reputation in a positive way. So you just search for my name and you'll find me everywhere I'm active.
Yeah, for sure. We'll link you in the show notes as well. But yeah, thanks for coming on, AJ. Always great to talk to you.
Absolutely. Thanks so much, Alex. Have a good one.
Yep.